Hello and welcome, beautiful people. This is part 3 of your Module 11 review. We have gone over elimination, we have gone over graphing, and then in this part we're going to be doing substitution. Again, warning, if I make a mistake, it's okay. I'm human. Just let me know. Also, if you hear a loud bell, also I apologize for that because I am still on campus and the bell might go off, so I apologize in advance. I already have my highlighter here because I see that in this part we are starting off with a keyword. This keyword here is substitution. So that means we have to use this method, okay? We can't use any other method. Even though I know you would really want to use a different method, don't do it. Now in this section, I might be able to squeeze in 2 examples instead of just 1. So let's start with number 9. So number 9 sometimes has a hiccup because you guys overthink questions like this, and that's okay because we're so accustomed to having something that's like super duper difficult. So this one kind of scares you in a little bit. All right, number 9, the objective of substitution, the whole point of substitution is to substitute for a variable. You're going to plug in something for something. And that sounds funny because it's like plug in something for something, but bear with me. Okay, here I have, let me get something out here. Here I have negative 6x minus 2. Okay, right here, negative 6x minus 2. Here I have 5x plus 9. And I'm actually going to go off tangent here a little bit. I'm going to go off to the side. And I'm going to write these really, really big. Y equals negative 6x minus 2. And y equals 5x plus 9. I wrote this so big I have to zoom out. Okay, there it is. So y is negative 6x minus 2. So negative 6x minus 2. So I'm just going to cover this up. I hope we can all agree that negative 6x minus 2, same thing, right? Same thing. All I did is I copied down the number. So y is equal to negative 6x minus 2. And I'm going to do the same thing for the bottom. Y is equal to 5x plus 9. Whoop, there it is, 5x plus 9. Yes, do we agree? Nothing really changed except those terms are just written on a sticky note now. All right, I'm going to do something even wilder. I'm going to take this bottom one, 5x plus 9, and I'm going to say 5x plus 9 is the same thing as 5x plus 9. Yes? Maybe? Again, I'm going to 5x plus 9 is 5x plus 9, so I'm just going to take my sticky note and I'm going to cover this y. So this y is actually 5x plus 9. How do I know? Well, because it tells me y is 5x plus 9. So 5x plus 9 is 5x plus 9. Yes? Okay. Now let's do the same thing here. If I know y is negative 6x minus 2, that means that negative 6x minus 2 is negative 6x minus 2. These two are equivalent. These two are equivalent. Like if we had to balance one of these balances, yes, and we had a y here and a negative 6x minus 2, they would balance, right? They would balance. They would be all balanced out. But if I wanted to, I can say, hey, I no longer want this y. I can say this balance will still be balanced if instead of y, I have a negative 6x minus 2. These are going to be all balanced out. Here's something even crazy. Do you guys see how this is y? And this is y? Hold on, y and y. here's something even crazy. If I know that this y is equal to negative 6x minus 2, and I know that this y is equal to 5x plus 9, and this y I can cover up with negative 6x minus 2, we can actually take this sticky note, and because this sticky note is y, I see another y here, and I can place this sticky note here, and I can place this sticky note here. We know that this, let me do that again. We know that this negative 6x minus 2 is equal to y. I'm going to cheat a little bit. Here's y. Y is negative 6x minus 2. Y is 5x plus 9. And then if I switch their place, I'm going to, again, remember I wrote that cheat? 5x plus 9 is y. Do I have y underneath here? I do. Negative 6x minus 2 is y. Do I have y underneath here? I do. So instead of writing negative 6x minus 2, I can write 5x plus 9, and this balance will still be balanced. These two things are equal because this is y and this is y. So when we are substituting, we are going to be taking our 5x plus 9 and substituting, replacing the y with 5x plus 9. Or you can take your negative 6x minus 2 and replace the bottom y with negative 6x minus 2. All right, let's go back to our worksheet. Let me zoom in. So we are taking our 5x plus 9 and we are going to replace y with 5x plus 9. So I'm going to substitute it. So what I really have is 5x plus 9 equal to negative 6x minus 2. Once we are here, once we've substituted, we can combine like terms and solve. I'm going to add 6x to both sides. So this is 11x. I'm going to bring down my plus 9, bring down my equals, and bring down my negative 2. I'm going to subtract 9 both sides. My 9's are equal to 0. Bring down 11x is equal to, this is negative 11. Divide by 11 both sides. X is equal to negative 1. Now is that our answer? No, that's not our answer. No, no, no. This is part of our answer, but that is not our complete solution. So now we have to do exactly what we did with our elimination. We take our answer and we're going to choose an equation. Which equation do you want to choose? Doesn't matter. Pick one. I'm going to choose the bottom one. Why? Get it? Why? Because I want to. I'm going to take my x and I'm going to substitute it, plug it in. Excuse me, I'm going to take my negative 1. I'm going to substitute it, plug it in for x. So I have y equals 5 times negative 1. You must use parentheses. So y is equal to negative 5 plus 9. So y is equal to, what is this, 4? Is this our answer? No, it is still not our answer. So what our answer is a combination of these 2 points. These 2 points have a relationship with each other. They must be grouped together. And the way we group these two is as an ordinate pair. So we have negative 1, comma, 4, and this is our answer. Okay? All right. I'm going to pause it. We're going to do one more. Okay? We're going to continue in part 4.